Hello, welcome to the video on the Pythagorean theorem. This is our third example set C. So this is an interesting set of problems here. We're going to use the theorem to determine whether each of these triangles is a right triangle. Okay, so A, B, and C all refer to the lengths of a triangle, potentially a right triangle. So some of you might be wondering, well, if I was to draw this, which side is what? Well, all you have to remember is that the longest side is the hypotenuse. So in this case, C is 13 is the biggest number here, so that has to be the hypotenuse. And likewise here, if you keep just scrolling down, you'll be able to determine which numbers are the hypotenuse. So knowing that, let's go ahead and use these values to determine whether these are the lengths of a right triangle. Okay, so we have a squared plus b squared equals c squared. That's the Pythagorean theorem. That's the relationship amongst the sides of a right triangle. Now if a squared plus b squared doesn't equal c squared, well, these cannot be the lengths of a right triangle. So let's go ahead and plug in information. So I get 5 squared plus 12 squared, and the question is that the same as 13 squared? Okay, so hopefully you have your triangle. Why don't you take a moment there to figure that out. So obviously 5 squared is 25 plus 12 squared, which is 144. So let's see what 13 squared is. Okay, 169. So is 144 plus 25, 169, and we can see that it is. So 169 equals 169. This checks out. All right, so this is, okay, if we were to draw this out, a right triangle. These are the lengths of a right triangle. And by the way, I just want to quickly review something that we learned in the lesson. This is actually a Pythagorean triple because the sides here are whole numbers. So 5, 12, 13 is one of those combinations of lengths that we call Pythagorean triple, where each side is a whole number value. Okay, we don't have a radical or a decimal. So let's go ahead and take a look at the next two set of problems. Okay, give myself some room here. All right, so a squared plus b squared, we're going to do the same thing here, equals c squared. Now some of you might be tempted to look at this a squared here and say, well, let me go ahead and find out what the square root of 63 is on my calculator. You don't need to do that. So I'll show you exactly what to do here. So here's 63, this is our value, we're going to square it, plus b squared, which is 23, squared, and we have to see if that is going to be equal to 25 squared. Okay, so the square root, or the square root of 63 squared is simply 63. Okay, so no need to put that in your calculator and get a decimal. Plus 23 squared, let's go and figure that out. That's 529. Let's just get our total now here. So 529 plus 63 is 592. All right, so now what we have to determine is 25 squared, 592, and it's not. Okay, 25 squared is 625. So because 592 does not equal 625, in other words, a squared plus b squared did not turn out being the same as the hypotenuse squared, c squared, these cannot be the lengths of a right triangle. All right, so hopefully you have the general idea now how to do this problem. So let's go ahead and take a look at the last one. A squared plus b squared equals c squared. So I have the square root of 82 squared plus 41 squared, and that equal to 1561 squared. Okay, so we have 82 plus 41 squared is 1681, and that equal to 1561. Okay, well clearly it's not, because when you add these two up, there's no way that you're going to, it's going to be much longer than this side here. And basically this is the general idea behind using the Pythagorean theorem. You can use it to determine where determine whether lengths of sides form a right triangle, or if you know, in fact, that you're dealing with the right triangle, you can obviously find the missing side. Okay? All right, good luck and keep practicing.